So this is my fourth book, and I came to Seattle for my first book on book tour, and I think 3 people came to my event. One was my friend, one was my cousin, and one was a guy who came in to take a nap. So thank you all so much for coming. When I first started writing this book about 6 years ago, I did not expect that we would actually be living through a pandemic of a brand new pathogen when it came out. But of course, here we are with the Zika virus spreading explosively across the Americas and across the globe, in fact. And this is really a good example of why I wrote the book. Over the past 50 years, we've had over 300 infectious diseases either newly emerge or reemerge into new places where they've never been seen before. So we've had Ebola in West Africa, never saw it there before. We've had novel kinds of coronaviruses that cause diseases like SARS and a new one called Middle East Respiratory Syndrome. We've had new kinds of avian influenza coming out of Asia, including one that caused the biggest outbreak of animal disease in US history last year. We've had a lot of new insect-borne diseases, from tick-borne illnesses like Lyme disease and others, West Nile virus, chikungunya, dengue, etc. So this sense that a pandemic, that is an outbreak of disease that starts in one part of the world and then spreads like a wave across global populations, is certainly growing. And that's not just me being worried, it's also the opinion of experts. So this was a 2006 study that was done among emerging disease experts who said, the majority said that they believed that a pandemic that would sicken 1 billion people, kill 165 million people, and cost the global economy $3 trillion would occur sometime in the next 2 generations. So the question is, which one? And we have a lot of contenders, right? We have 150,000 species of bacteria, nearly 1 million viruses that can infect mammals. So figuring out which one of all of these is going to cause the next pandemic is possibly something that won't be possible to do. But while we can't know which one, we can know how this happens, because in modern history, there's only been a few pathogens that have been able to cause pandemics. We've had Yersinia pestis, which caused the plague pandemics, influenza, which causes seasonal flu pandemics, variola, which causes smallpox, HIV, which causes the ongoing AIDS pandemic, and then the 5th one is Vibrio cholera, which causes the disease we know as cholera. And this is the one that interests me the most, in part because it's really deadly. It can kill you in a matter of hours. It kills about half the people who get it if they're not rapidly treated. But more than that, it's one of the most successful of all of our pandemic-causing pathogens, because cholera has caused not just 1 or 2 global pandemics, it's caused 7 global pandemics. And the latest one is still going on right now, just a few hundred miles off the coast of Florida in Haiti. So we think of cholera as a poor person's disease, and that is true today. But that wasn't true when cholera first emerged. When it first came out in the 1800s, it hit the most advanced cities in the world. Cities like New York, which was repeatedly plagued by cholera outbreaks in the 1800s. And not just New York, but also London and Paris and New Orleans and all these, the really most advanced cities of their time. And these weren't just very deadly. Thousands of people died. They're also highly disruptive. And this is something that's common when there's outbreaks of novel pathogens, is people don't know where they come from. They don't know why it suddenly arrived, they don't know how it spread, and they start to, in this face of all this uncertainty and panic, they start to blame each other. So in the 1830s, people blamed the cholera on the Irish. In the 1840s, it was blamed on the Muslims. By the 1890s, cholera was being blamed on the Eastern Europeans. And this wasn't just sort of social exclusion, this was actually violent scapegoating. This picture is from an excavation that was done in 2009 right outside of Philadelphia. It was a stretch of railway track. And what had happened there is Irish immigrants had come over in 1832 to work on the railway, and there had been a cholera outbreak. So the local community sort of quarantined the valley where they were staying. But then secretly, they came back, and they massacred all of them. And they buried them in this mass grave which is where recently archaeologists found their smashed skulls and bullet-ridden skeletons. But it wasn't just marginalized communities that were attacked and scapegoated, it was also healthcare workers. So physicians during cholera outbreaks were routinely stoned in the street. Mobs would form at cholera hospitals and they were often burned down. There was a frequent kind of social phenomenon called cholera riots, and this is like a common thing that happened when there was outbreaks of cholera. So the question I want to ask is, how does a little microbe cause all of this craziness and death and destruction? I mean, you think about a microbe, it doesn't even have any independent locomotion. So what I wanted to look at is how does a little microbe turn into this pandemic-causing pathogen? And what I found is, there's really a multi-step process, and a lot of it, some of it has to do with science, but a lot of it has to do with how we live. So cholera actually originates in the environment, and this is true of a lot of our new microbes today. Cholera is a marine bacteria. It naturally lives in estuaries, coastal waters around the world, especially places like the Sundarbans, which is what's pictured here. This is where the major rivers of South Asia empty into the Bay of Bengal. So the water there is sort of half salty, it's half fresh, it's quite warm, it's quite alkaline, and the bacteria just naturally lives in this environment in the water. It actually lives in conjunction with zooplankton. And in that environment, it performs a useful ecological function. It helps to recycle nutrients. And for a long time, people didn't live in places like the Sundarbans. This is a place that's covered in mangrove swamps. There's crocodiles, there's tigers, there's cyclones. It's flooded by the tides twice a day. So, people didn't come into contact with the bacteria very often. Of course, that all changed in the 19th century, when the British Raj decided to settle the Sundarbans and turn them into rice fields. And so over the course of that century, 90% of the Sundarbans was settled. And quite suddenly, humans had invaded cholera habitat. And we came into novel contact with that bacteria. And as we did that, the bacteria came into our bodies and started to adapt to us. And of course, inside our bodies, cholera bacteria is not a particularly useful part of our habitat. If you ingest a little bit of cholera bacteria, it lines the interior of your gut. And it actually reverses the normal functioning of that organ so that instead of nourishing the body with fluids, the cholera-infected gut actually extracts fluids from the body and expels them in a massive torrent of watery diarrhea and vomiting. Actually, a person infected with cholera can lose up to 15 liters of fluid a day, and that's what kills you. You just die of dehydration, essentially, in a matter of hours. So it kind of desiccates you alive. And of course, each drop of that waste that is teeming with the bacteria. So anyone who comes into contact with it on their hands, in their food, or in their water, the bacteria will spread to them too. So the first pandemic of cholera started in the Sundarbans in 1817, and it spread up into Russia, went out into the industrializing cities of Europe. But of course, to cause a pandemic, it would have to cross the oceans. Now, all of this was perfectly timed with the arrival of the steam engine. So this was the era, the new industrial era, and we transitioned from sail ships to steamships. And this allowed people to start traveling across the ocean a lot faster. Instead of 8 weeks, it would just take a week to cross the ocean. In addition, we had all these nice waterways here in the United States, but we only could go downstream until we had steamships. Then we could go up and down. Better than that, we used steam engines to build canals. So the Erie Canal, for example, opened in 1825, connected all of the waterway traffic of the Atlantic with the interior Mississippi Valley, all of those waterways. So we had created this kind of seamless watery network, and it was perfect for cholera to come over from London and Paris into Canada and then filter out throughout the interior of North America. And of course, all of this meant that a lot of people were moving too. People were abandoning farms, coming into the cities for the new factory jobs. Places like New York, there would be about 77,000 people crammed into every square kilometer there. Because there wasn't any room to sprawl, of course. Everyone had to live near work or near the possibility of work. So people were coming into much closer contact. They were breathing on each other more, they were touching each other more. And of course, all of this would create a huge sanitary crisis. People simply kind of transplanted the ways they managed human waste in the countryside into the cities. The city life was a new thing. And so people used cesspools and outhouses and privies. And there was no sewer system to carry this stuff away or treat it. There wasn't even any laws that said you had to empty out this stuff. So all this material was allowed to kind of sit and build up and then spill out into the streets and into people's wells and down into the groundwater. A typical 19th century New Yorker was actually ingesting about 2 teaspoons of fecal matter every day. So as soon as cholera entered into this environment, it was just able to explode. And that happened again and again over the course of the 1800s. Of course, there was things we could do. We don't take these things lying down. But at the same time as all of this was happening, this was the era of the robber barons, right? So private interests had become incredibly powerful. And sometimes they were directly in conflict with the public health strategies that might have contained cholera. So for example, in 1832, doctors collected this data showing that, a pretty clear picture, cholera is coming down the Hudson River and the Erie Canal and it's heading straight for New York City. So the obvious thing to do to protect the city would have been to quarantine the waterways. But private interests thought that would be far too disruptive. And so they never did it. And cholera came down those waterways, infected New York again and again. In fact, there was companies who were making money distributing cholera-contaminated water to the people of New York. The epicenter, a lot of the epidemics occurred in this slum called 5 Points. If anyone has seen that Martin Scorsese movie, The Gangs of New York, that's about 5 Points. So this is where a lot of the epicenter of the epidemics was. And this slum had actually been built on what was once a pond. That was the only source of fresh water in Manhattan when it was first settled. It was called the Collect Pond. It was filled up with garbage, and then the slum was built on top of that pond. So the ground underneath was unstable. It was, low-lying. And of course, the groundwater underneath that was very easily contaminated with all of these cesspools and privies of the slum on top of it. But the company that the state of New York chartered to deliver water to the people of New York, they didn't want to spend a lot of money. They didn't want to spend the money that would be required to tap upstream sources of water, which would have been cleaner and fresher and would have tasted better. They wanted to save money, so they did sort of like what happened in Flint, Michigan, sadly. They sank their well right in the middle of that slum. And they delivered that water to 1/3 of the people of New York. And this was through multiple cholera outbreaks. And the reason they did that, actually, is because they wanted to start a bank. They wanted to save all the money to start a bank. And that bank actually became, it worked in the sense that it became a very successful bank. Does anyone know what the Bank of the Manhattan Company is known as today? Chase? Yes, J.P. Morgan Chase, biggest bank in America. So there's things doctors could have done at the time, too. The cure for cholera is not technically very difficult. It's basically clean water. You just have to rehydrate people. But doctors at the time were beholden to a theory about how diseases spread called miasmatism. And this was the idea that diseases like cholera essentially spread through bad smells. They were called miasmas. They were smelly airs that kind of rose up from wetlands or decomposing organic material. And so this theory kind of made sense for old diseases like, say, malaria, which was common at that time too. Malaria isn't carried in smelly airs, but mosquitoes that carry malaria do rise up from wetlands and sort of sulfurous swamps and things like that. So miasmatism might have worked for some of the old diseases, but for new diseases like cholera, this theory of miasmatism actually could make things much worse. So, for example, in the city of London, people had started installing flush water closets, as they call them, or what we know as flush toilets. And they did this because they thought it would be healthy, that you would get rid of all these miasmas from human waste. You get rid of all the bad smells from your homes and your streets, and you flush all this stuff away, so that would make you more healthy. But since all they cared about was the smell and not the contents, they didn't mind that they actually flushed all of their waste directly into the River Thames, which was the source of their drinking water. And in fact, after every cholera outbreak, people in the City of London would install more flush toilets to dump more of their human waste into the drinking water rather than less. So the big question, of course, is, could this happen again? And I went around to different places, and I went to South China and Hong Kong and Port-au-Prince and New Delhi and elsewhere, trying to find where new pathogens were emerging and how this story of cholera could kind of shed light on what will happen with these new pathogens and what factors are driving them forward. And I found it's really many of the same drivers that pushed cholera into human populations in the 19th century are being recreated today, but on a global scale. So we're invading wild habitat on an unprecedented scale. And that's because our populations are growing and also our industrial activities are growing. And what happens here is that we invade wildlife habitat or we disrupt wildlife habitat. Either way, humans and wild animals come into novel kinds of contact, and that allows their microbes to spill over into our bodies. 60% of our new pathogens today are coming from the bodies of animals. That's 70% of those are coming from wildlife. And a good example of that is Ebola virus. So a huge swath of the continent of Africa is being deforested right now. And it's not just because populations are growing and farms and mines are expanding, it's also because of political violence. Those three countries on the westernmost point of West Africa, Sierra Leone, Liberia, and Guinea, over the course of the 90s were involved in a very complicated, very violent political conflict. And what happened is about 600,000 people, refugees, fled into this one area where these three countries meet, Guinea, Sierra Leone, and Liberia. Right in the middle there where they all meet was once one of the most biodiverse forests in the world. It was called the Guinea Forest region. So 600,000 people flee into this forest to get away from the violence. And then what happened is visible from space. These are satellite pictures of where those three countries meet. And you can see in the inset, that was taken in 1970. It's almost all green. But then this larger one is from 1999. And you can see that area that was once all green is now mostly brown. Only 15% of that original forest remained afterwards. And what we now know is that that whole area that's being deforested overlaps pretty well with the habitat of fruit bats. And so as people come into more intimate contact with the fruit bat, the viruses and microbes that live in fruit bats can spill over into our bodies. And we now know that fruit bats are reservoirs of Ebola virus. So as people started living near bats, we started getting Ebola virus, and that happened in West Africa in the end of 2013. A 2-year-old child who was living near the Guinea Forest region in a village. He's known to have been playing near a tree where bats were known to roost, and so whether he was exposed to bat saliva or bat excreta, Ebola virus infected him. And then he infected his family members. And then they infected their healthcare workers, and they infected their family members, and on until we had the biggest Ebola outbreak in history. Over 11,000 people died. It's more than all of the previous Ebola outbreaks that had occurred combined. But this isn't just happening in far-off places. This is happening in the United States as well. A good example of that is West Nile virus. So West Nile virus is a virus of migratory birds from Africa. They land here by the millions. They've been doing that for a long time, especially places like New York City, which is on the flyway that they land on. But we didn't have West Nile virus in humans until pretty recently, because we had very diverse bird flocks. And we have lots of diversity of species. Some of those species they're not really vulnerable to West Nile virus. If you have lots of species like woodpeckers and rails, they actually repel the virus. So as long as you have all these diverse species around, you don't have that much West Nile virus around in your birds. But what happened over the past 25 years or so is we've lost a lot of that avian biodiversity. So we don't really have a lot of woodpeckers and rails anymore. What we do have is a lot of robins and crows. Those are birds that can live anywhere. American robin populations have actually doubled in the last 25 years. And it turns out that unlike woodpeckers and rails, robins and crows are really good amplifiers of West Nile virus. So the fewer woodpeckers and rails you have around, and the more robins and crows you have around, the more virus you have around, and the more likely it becomes that a mosquito will bite an infected bird and then bite a person and pass on West Nile virus. And that's exactly what happened in 1999, the first outbreak of West Nile virus in the United States. And since then, it has steadily spread across the nation. This is a picture of all of the counties in the United States where West Nile virus-infected birds have been found. Similarly, the northeastern forest, when it was intact, we had a diversity of woodland species. We had deer and mice, and we also had chipmunks and opossum. But we started breaking that forest up into little suburban plots. And when we did that, we lost the opossums and we lost the chipmunks. The deer and the mice, they stayed. They can live in this patchwork forest. Well, it turns out that opossums, the typical opossum actually destroys about 6,000 ticks a week through grooming. But a typical white-footed mouse destroys about 50 ticks a week. So the fewer opossums you have around, and the more mice you have around, the more ticks you have around, and the more likely an outbreak of tick-borne disease becomes in people. And that's exactly what happened in the late 70s when we had the first outbreak of arthritis in children, which we now know is caused by what we know as Lyme disease. And that disease has also steadily spread across the country, of about 300,000 people being diagnosed with Lyme every year. So we're driving pathogens into human populations through all of these new ways, and then we're actually allowing them to amplify in our cities. So that process of urbanization that started in Cholera's time in the 1800s is sort of reaching its peak now. So by 2030, the majority of the human species will live in cities. And they're not going to be cities like Seattle and Washington, D.C. They're going to be cities more like Monrovia and Freetown in West Africa. Ad hoc development, lots of slums, not a lot of infrastructure. About 2 billion people will live in slums by then. So we've already seen this kind of massive urban expansion, and new pathogens have already taken advantage of this. Ebola, for example, we've had Ebola outbreaks since the 70s. But it had never infected any place with more than a few 100,000 inhabitants. In 2013, when it broke out in Guinea, within a couple weeks, Ebola reached 3 capital cities with a combined population of nearly 3 million. And this is one really big reason why it was such a huge conflagration. Similarly, Zika virus, we've had Zika virus since at least the 1940s, possibly before that. But it occurred mostly in the equatorial forests of Africa and Asia, and people didn't really get it. And that's because it was carried by a forest mosquito, which mostly bit animals, not people. Now what we see is Zika virus is being carried by Aedes aegypti. This is a mosquito that specializes in cities, and it has dramatically expanded its range as our cities, especially in the American tropics, have gotten so much bigger. This mosquito can live it breeds in like a bottle cap with a little bit of a drop of water in a bottle cap, that's what they say. Aedes aegypti mosquitoes can breed in that little water. So they thrive in all of our plastic garbage that we leave around. And unlike those forest mosquitoes, they only bite humans. And so there's a big reason why Zika is spreading so explosively right now. But we're not just crowding people together, we're also crowding our animals together. We have more animals under domestication now than in the last 10,000 years of domestication until 1960 combined. So we have a huge number of animals that we're rearing for our need for protein and our demand for meat. And many of those animals are living in these giant factory farms where there's like 1 million individuals or more crowded together. So they're basically living in the animal equivalent of a slum. And these animal slums perform the same function as our human slums do. They allow pathogens to replicate really rapidly, evolve, and become more virulent. And one example of that is avian influenza. Avian influenza normally lives in wild waterfowl, doesn't really make them sick. But when those viruses drop into these factory farms full of captive birds, they start to spread really fast, they start to mutate, and they become more virulent. And we've had an increasing problem with more and more of these novel kinds of avian influenza emerging out of these factory farms, including some that can infect humans. And this, of course, is causing a new kind of sanitary crisis. Now, we still have 2.6 billion people around the world who have no access to modern sanitation. But on top of that, we also have 7 billion tons of animal excreta produced every year. And this is far more than we can possibly use in the old way, which is what we're still trying to do, which is as fertilizer for croplands. But croplands can't absorb this huge volume of animal waste. And so what farmers are doing is just collecting it in what are called manure lagoons, which is pictured here. It's basically an unlined open pit full of animal waste. And so when it rains or when there's storms, this material washes over into the environment. And pathogens are already taking advantage of this. So about half of all American cattle on feedlots are infected with a kind of E. coli called Shiga toxin-producing E. coli. It's a virulent form of E. coli. It doesn't make the cattle sick. But because cattle waste is so often contaminating our food and water, we have 70,000 Americans getting sick with this virulent form of E. coli every year. Then, of course, we're spreading this stuff around. And our flight network is probably the most efficient way of disseminating pathogens we could possibly have devised. We have not just a few airports in capital cities, but hundreds of airports, and even in small towns, and tens of thousands of connections between them all. So if a pathogen emerges in one part of the world, as the simulation of a flu pandemic shows, it can very rapidly spread across the planet. And in fact, our flight network is so decisive in shaping how epidemics spread that you can actually predict where and when an epidemic will next strike just by measuring the number of direct flights between infected and uninfected cities. So if you run that same flu pandemic on a map like this, which shows cities in relationship to their direct flights that connect them, you can see it just resolves into this perfect series of waves. So there's all these ways in which modern life is pushing pathogens and increasing the risk of pandemics. But of course, we still have all of our defenses, and in fact, they're much better now than they were in the past. But we still have challenges, too. So of the 100 biggest economies in the world today, only 49 are governments, 51 are corporations. And so what we find is when public health strategies interfere or conflict with industry interests, we're not able to contain pathogens as best as we can. One example of that is antibiotic-resistant bacteria. So we've known since the 1940s at least that if we use antibiotics in a way that's not medically necessary, we will encourage the emergence of drug-resistant bacteria. And yet, in the United States today, 80% of the antibiotics that we use are used for commercial reasons. They're not used for medically necessary reasons at all. That's 29 million pounds of antibiotics every year. They're used in agriculture in low doses to feed sort of factory farm animals and help them grow faster. So we've known this is happening, and we have 23,000 people dying of antibiotic-resistant bacterial infections every year. And yet, we've only made the tiniest baby steps to try to contain that problem. Our medicine is definitely a lot better than it was in the 19th century. We can very rapidly come up with cures and vaccines and killing chemicals against insects that carry disease. But I would argue that there still is a mismatch. So we see a lot of these pathogens are coming out of animals, they're coming out of wildlife, they're being driven through human populations through social and political factors. So you would think then that the best way to tackle this problem is through a collaborative approach, multidisciplinary approach. Get the wildlife biologists, get the veterinarians, get the ecologists, and get the doctors, and also get the epidemiologists, and also get the social scientists and the anthropologists. But that's not what we do. The way we tackle contagion is through solely a biomedical approach, which is to kind of reduce this complex problem to its tiniest aspects and then attack those with sort of surgical precision. An example of that is dengue in Florida. So dengue virus is a mosquito-borne virus, first emerged in Florida in 2009, hadn't been there in 70 years. And it was immediately attacked according to the biomedical paradigm, which is isolate the insect, isolate the virus, and zap it with killing chemicals. And that's what we did. But of course, Florida has been surrounded by places where dengue's been endemic for a long time. The mosquitoes that carry dengue have been present in Florida for a long time. So there was no invasion of mosquitoes, as our response would have suggested. What had happened is, in 2008, we had the foreclosure crisis. And that hit Florida particularly hard. And so across Florida, there was all these abandoned homes. And of course, since this is Florida, that means there's a lot of empty swimming pools. And so when the rains came, these empty swimming pools filled up with standing water, and they became giant mosquito hatcheries. No one was home to notice, no one was home to let the mosquito inspector in, and lo and behold, a year later, we had this unprecedented outbreak of dengue in Florida. Now, I don't know if addressing the housing crisis would have helped to prevent or contain the dengue outbreak in Florida, because no one tried that. But what I would argue is that the biomedical approach has failed, in that dengue is now considered endemic in Florida. It's a permanent part of the landscape there. So what to do? This is obviously not Nostradamus, right? This is not a crystal ball. This is not what's definitely going to happen. This is a prediction of what will happen if we don't change. And there's a lot of things we can do. So this is a typical curve of what happens, cases over time, an epidemic curve, where a pathogen enters a susceptible population, starts to grow, spread exponentially, and then as people either die or get sick or get immune, it starts to collapse. Right now, the earliest that we start to attack these outbreaks is around there, and that's at best. So for the Ebola epidemic in West Africa, we actually got most of the effort was put into place after the peak of that epidemic. But the best we can do is right there, but at that point, we already have exponential growth of untreatable disease. So what if you push that back to there and start to detect these things before they start to spread exponentially? And that's possible now. So we don't know where the next pathogen will emerge, but we do know how it happens. And since we know how it happens, we can predict where it's most likely to happen. So this is a map of hotspots of where new pathogens are most likely to emerge. These are places where there's a lot of biodiversity and people invading wildlife habitat, rapid urban expansion, lots of slums, lots of intensification of agriculture, lots of flight connections, or some combination of all of those things. So in those places, we can do active surveillance for looking at microbes and seeing if they're changing in ways that could allow them to spread in human populations. And when we find them, we can start to contain them and stanch them before they hop on a flight. And this is actually happening in an ad hoc way right now with NGOs and academic groups and some state governments actually involved in this work of doing this active detection, active surveillance, looking for microbes and how they might be changing. And of course, there's a lot of things we can do as citizens. So, there's things we should do to be responsible in this age of pandemics. We have to all take care that we're not going to be part of the problem spreading contagions. But I think really the most important thing is that we need to be informed. The big missing element in our global health response, from what I can see, is public engagement. We really have left this whole business up to our biomedical establishment, and we haven't become involved as citizens, and I think that really needs to change. So ultimately, what this story of pandemics has taught me is that human health is really connected to the health of our animals, the health of our wildlife, the health of our societies, the health of our ecosystems. And I think once we begin to see that, we can start to actually prevent pandemics from occurring at all. We can do things like restore wild habitats so that the microbes in animals stay in animals and don't spill over into our bodies. We can do things like protecting the health of the most vulnerable among us, people who live in slums, animals that live in factory farms, people who don't have access to sanitation and water and basic health care. These are all things we can do that I think put together can dramatically reduce our risk of pandemics. Thank you so much for listening.